Yesterday I was discussing about the stability of the different oxidation state. Okay. And there I mentioned the last one is the thermodynamic stability. And I told you that if you compare the stability of the nickel compounds, so nickel compounds are more stable in +2 oxidation state than platinum +2. And when it is for the tetravalent compounds, we find that platinum +4 compounds are more stable than the nickel +4 compounds. And one more thing I told you, that copper, though in its +1 oxidation state, though it has D10 configuration, but it is found to be less stable than the copper +2 compounds, because I told you that is because of the hydration enthalpy. So you will find that in case of copper, in case of copper, we find that copper 2+ compounds are more stable than copper +1. Though, if you go by the electronic concept, it is supposed to be more stable. It is D10 and it is D9. Why it is more stable? Because copper 2 ions are smaller and it can be easily solvated. So we find that cuprous fluoride, cuprous chloride, cuprous bromide, these compounds are unstable in aqueous media. While cuprous iodide, Cu2I2, is more stable than Cu(I2) in aqueous media. Very, very stable. And this from here, the question also comes. Is right. Is so. See, when we take cupric iodide in aqueous solution, so it gives us Cu2 plus and 2I minus. So right here now, iodide ions are strong reducing agent. Why iodine is a strong reducing agent? Why iodide wants to give electron? Because iodine has the least electronegativity. It cannot hold negative charge for a long time. Due to poor electronegativity. Other Halogens are more electronegative, so it can hold negative charge for a long time. And it reduces copper to ions to copper 1 ions in aqueous medium. See what happens. Right now here 2I minus is I2 plus 2A. And 2Cu2 plus 2 electron gives you 2Cu plus. So make a solution. It gives you 2Cu2 plus 2 minus C2Cu plus and I2. So this is the ion electron method of reaction. Okay. So if I write its complete reaction like this, so I can write here 2 cupric iodide will give you Cu2 I2 plus I2. This is the chemistry behind, and this is the equation. This is important for exam. Okay. So now formation of colored compounds. See, most of the transition material compounds are colored. Okay. Most of the transition metal compounds means what? Where from the color comes? Color comes from the ions. Or so color does not come from the anion. Color comes from the metal side. Huh? Color. Why? I have been repeatedly telling you. Color always comes from the electronic excitations. And that is also unpaired electron. Transition elements have lot of unpaired electrons in their d orbitals, which absorbs the energy from the visible light and undergoes electronic transitions. This theory I shall explain when I go to coordination compound. It is because of the presence of unpaired electrons in their d orbitals. Wait. Absorb visible light and undergo electronic transition to higher energy states, okay, or undergo DD transition. See how to explain now. Anyway, I'll telling you. Whenever transition metals are forming compounds, see, this is the d orbitals. We know all these d orbitals have the same energy. Okay, so this is the d orbitals. Of transition metal ions. All of them, they're same energy. Now, compound is being formed by metal cation and the anion. So when ask ময়লা না হলে লইব আর অল্প ময়লা আছে কেন বাইরে তো মাত্র থেকে তার থেকে বান্ধি আনতে বন্ধ হইল না কিন্তু বন্ধ নাই জীবন কিছু না okay. See here. So when this anion comes near to it, their energy is little bit raised. Okay. The energy is little bit raised. Now, after that, we know that this the 5d orbitals. Out of the 5d orbitals, 2 are along the axis and 3 of them are in the plane. Okay? So I don't know how to explain to you there. See? This is the metal ion. Okay? So it is, say it is X, X. Okay. X, X. Y, Y. And this is Z. So we have dxy, dyz, and dzx. Okay? And here it is dx square minus y square and dz square. See, dx square minus y square, it lies along the this. This is dx square minus this is orbit. Then dz square dz square orbital is along the z-axis like this. These two along the axis. And they lie in the plane. See here. What is the plane here? So it is z, this is x, this is y. See, this is the plane. See here. Okay, like see here. This is the dz. Okay, this is x and this is y. So this is the dxy plane. This one. Okay. Now this is z, this is x, and this is y. One more plane is there. So if any orbital lie in this plane, this is dyz, and this is the x plane. So z is there. So if it anything lies here, this is the dyz plane. All right. So in that case, you will find the so in such case, when the anions approach, if the anions approach along the xy plane, so in that case, they, because anions comes with the electron, and dx square minus y square also have electron. When they come nearer to each other, they repel. Due to repulsion, what happens? This energy of these orbitals are distorted. Huh? See here, in this case, if they come along the plane, this dx square minus y square and dz square, they suffer repulsion and the energy increases. And other three of them do not face any repulsion, so their energy is lowered. Suppose, say, I'm talking to a person, suddenly I feel that I think he may hit me. So is it not I immediately push back? I do not go and embrace him. So similarly, when dx square minus y square, they're finding the anions are approaching towards them with the electron, they suffer a repulsion and it goes down. So what is this now? You need not draw dxy, dyz, and dzx. See, now no longer the energies are same. This is called splitting. And the energy which is energy difference between these two, yesterday I told you, that is called crystal field splitting. So what happens now? Suppose you have an electron here. Then this electron, it follows the Ahava principle. So it goes here. So because of the presence of this unpaired electron, whenever the light falls on it, it absorbs an electron from here, it goes here. When it goes here, the color is emitted. See, this is also d orbital, and this is also d orbital. Because of that, I have written here dd transition. So any transition metal ion, if it contains unpaired electrons, in that case, it will be colored. And if the electrons either paired up or if electron is not there in the d orbital, they will not be colored. Okay, I'll show you one. Only this much you have to write. You don't have to spend so much writing on this thing. When you go to coordination chemistry, then you can explain by this diagram. Say, I have taken here scandium, 3 plus ions. Will it be colored or not colored? See, scandium electronic configuration is what? AR. Scandium is 21. So from 21 electrons, 3 you have to subtract. So I'll write now here 18. Then what I'm supposed to write? 3d 4s. All right. So it is, after that electron goes here. It is 4s. Then after 4s, it goes to 3d. So s can accommodate 2 electrons. So plus 2. Then after is what? Plus 1. So it is 21. All right. Now in scandium 3 plus, this ion goes out, this electron goes out, this also goes out. So what is the electronic configuration? Only air. So scandium 3 plus has no electron in the 3d orbital. As it does not have any electron in the 3d orbital, that compound will be colorless because no electron is given. So your answer will be the scandium 3 plus ions are colorless due to the absence of only one statement you put. You don't have to draw all these things. Scandium 3 plus compounds are colorless due to the absence of any unpaired electron in a d orbital. Okay. If the question is like this, titanium 3 plus, titanium 22. See here, titanium. So it is what? 18 plus 2, 20, 20 plus 2, 22. All right. So now, as it is titanium 3 plus, what is the electronic configuration? See, this will not be there. And from there, 1 will go. So what will have now here? 1. So right now here, 3d1. So initially, which I drawn, is nothing but the titanium 3 plus. So titanium 3 plus compound will be colored. Now, if it is titanium 4 plus, this is also not there. This will be what? 3d0. So titanium 4 plus compounds will be colorless. Titanium dioxide does not have any color, it is a white powder. Okay, let me go for now. I told you no that copper 1 compounds are colorless. See here, what is the copper? Copper is 29. We know copper is 3d10 4s1. Okay, now if I write here copper plus, so what will happen now? Copper plus means this will go. So it is Ar. Then 3d10. Now see here, what is going to happen? Does it have any unpaired electron? It does not have any unpaired electron. So I'll write it here like this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Does it have any unpaired electron? No, it doesn't have any unpaired electron. So all copper and compounds are colorless. So you don't have to go for such complicacy maintaining all these orbitals. Simply write undergo d transition. Okay. So now we'll write here next is magnetic property. Again, this question is C. Magnetic property. Most of the transition metal atom and their ions are magnetic so magnetic properties. Why? It is due to the presence of unpaired electrons in their d orbital. That we have already learned from our solid state. We found any species having unpaired electron, they are paramagnetic in nature. So they show magnetic properties. So, but now there is an empirical formula by which you can find out their magnetic moment. So their magnetic moment can be theoretically calculated from the following equation. Okay, we write here spin only. I'll tell you what spin only. Okay, this n into n plus 2 bm. Bm is the unit. So what is n? So what is mu? Is spin only magnetic. What is n? N is the number of unpaired electrons. And what is Bm? Bm is the unit. It is called Bohr, B-O-H-R. Bohr magnet.
Sir, that is spin only, sir.
Yes, spin only.
Okay.
Sometimes we write mu s also.
কম্বলটা ইউজ করতে লাগে বড় কম্বলটা ঠান্ডা পড়ে না ঠিক আছে
This I already told you. Okay. See here. This is the nucleus and here this is electron. Any electrically charged particle, whether it is an electron or proton, when they have a circular motion, then they generate a magnetic field. So now you know. Now we know that electrons move in the orbit. So when it moves in the orbit, it generates a magnetic moment. So we will call it now orbital magnetic, magnetic moment. But we know when electron moves in the orbit, this also spin around its own axis. Now on the basis of that, we have plus half and minus half spin or not. We have it. So this also generates a another magnetic moment. So we call that to be spin only magnetic moment. See, electrons are staying in different orbits. So in that case, they show different types of magnetic moment. So in that case, we find the most prominent is the spin only, because every electron moves with a similar speed when they spin around their own axis. So we calculate the magnetic moment on the basis of that, not on the basis of this. So this is called, this mu is called spin only magnetic moment. Okay, now suppose they ask you, calculate the magnetic moment of ferrous sulfate. So don't get scared. What is the oxidation state of iron here? Ferrous sulfate means it is 2 plus. So let us write down. What is the electronic configuration of iron? 26. See, this atomic number you have to remember for your exam. Only 10. Scandium to zinc. And it's very easy. Scandium starts with 21. Okay? So iron is 26. What is this electronic configuration? Yeah. 18. Then comes 4s2. So plus 2. Then comes what? Rest will be what? Huh? 26 minus 20 is what? 6. So I'll write now. So when I write Fe2 plus, though the electron goes to the 3D, but when electron is lost, always lost from the outermost shell. So what is this now? It is Ar 3d6 4s2. Now I have to find out how many electrons are there unpaired. So I'll write now here Fe2 plus, I'll write, see, 6. So 1, 2, 3, 4, 5, 6. So how many unpaired electrons are there? 4. So now I'll calculate mu is equal to root over n into n plus 2 b. Now n is equal to 4. So 4 into 4 plus 2 b. Okay. So it is how much it comes? Root over 24. So it is equal to 4.90. Magnetic moment of nickel sulfate. Everything is there. Nickel is 28. Atomic number 28. Please do. Nickel is 28. You should be able to do it. Good. 2 minutes. I don't take for it. What did you get? What is the value?
Root 8,
Huh?
root 8, 2.82.
Root what? Huh?
8,
Root?
8.
It can't be like this. How many unpaired electrons it has?
2.
2. Then it will be what?
2 into 2 plus 2.
Yes, I understand. But if you write root 2, so root 8 will not have. No, what is the exact value? Tell.
2.82 bm.
28.82 bm. See here, why I told you to do it. When you know the number of unpaired electron, then you can put it in this equation and you can immediately get it. But your entrance exam may not be like this. They may give you that the magnetic moment of a ion is 4.92. How many unpaired electron it has? So in that case, see here, you have to write that root over n into n plus 2 is equal to 4.92. See, mark would be 1. So what you will write now? You will write n into n plus 2 is equal to 4.92 square. Is it not? Then you will write here n in. So you will write now here twice n plus n square is equal to 4.92. Like this or not? Then you ultimately you will find that you are going to get, I'm not that good in mathematics and I totally forgot also many things, but I know in this process you will get 2 values of n. You have to do at least 5 or 6 minutes. Number is 1. So I'll tell you a shortcut. What about the first digit is the before decimal? That is nothing but the number of unpaired electron it has. See, in case of iron, ferrous, what did you get? Here the first digit is 4. Number of unpaired electron is also 4. In case of nickel, number of unpaired electron you already found it is 2. Is it not the magnetic moment starts with 2? Please remember, this is for your entrance exam. If it is the 1 unpaired electron, first digit of the magnetic moment will be 1. For 2, it will be 2. For 3, it will be 3. For 4, it will be 4. Maximum number is what? Unpaired electron in the orbital is 5. That also will be 5. So this is your shortcut and this is your trade secret. You need not go and dispense this knowledge outside to your friend to show that how intelligent you are. Later on in exam, you will forget, they will remember. Okay. Then I'm going to discuss about the catalytic property. Before catalytic property, I want yes, catalytic property. Most of the transition elements. Example, what should I write? Example. See, iron, cobalt, nickel, then platinum, palladium, okay, ruthenium, copper, etc. And their compounds are used as catalysts. Most of the transition metals are used in catalysts. Most. Why it is so? Surface chemistry, though I did not teach you, but you have read in your school. Okay, so there we have found that the theory of heterogeneous catalysis you have already read. Okay, catalysis is a surface phenomenon. So absorption of the reactant molecules takes place on the surface. So first it undergoes adsorption. After adsorption, see, this is the surface. Okay, so this is the surface. Then suppose you have taken A plus B to react. Okay, so A plus B is going to react here. So first the A plus B will travel near to the surface. So whenever the substances travel by themselves, in chemistry we call it diffusion. After they travel, they will come near to the surface. So it is A and B, and then they will settle. So settling on the surface is called adsorption. Then they are going to form. It's the first adsorption will be the physisorption or physical adsorption. Then they are going to form a temporary bond with them. That is, they are going to undergo chemisorption. Okay. After chemisorption, then they are going to interact within themselves. So they undergo a reaction within them. After the reaction is finished, all right, then they are going to form a product AB, and in that case, this bond is broken. So in that case, the moment the bond is broken, they are going to leave the surface. So when they leave the surface, the process is called what? We call it desorption. Okay. Then after that, they will move out from this place, so that fresh molecules can come. When they move out of this place, again we call it diffusion. So heterogeneous catalysis consists of 5 steps. Okay. So if you do not remember, try to remember in this way. How do you spell it? If you take these 5 letters, how to pronounce? Huh? D A R D. Can you pronounce it? Anyone?
Sir,
Yes. So if you do not remember, it's going to pain me. In Hindi, dard is pain. All right. So now why the transition metals act as a very good catalyst? Because now we know the theory. First of all, transition metals provides a very active surface area for adsorption. Very active surface area. Second, transition metals have unpaired electrons as well as vacant d orbitals to form temporary bond with the reactants. See, some reactant may come with unpaired electron. So the unpaired electron of transition metal and unpaired electron of the reactants will form bond. Or it may happen reactant molecules that may not have unpaired electron, but reactant molecules can have lone pairs. So lone pairs can be donated to the empty d orbital. They'll form coordinate covalent bond. All right. In this case, what you find that they can form the temporary bond, or what we call it, they form intermediates with the transition metals. Now, if I go towards compounds, when we have taken transition metal compounds, in that case, they do not remain in the form of metals, they form in the form of ions. So in this process, we have found that transition metals can acquire many oxidation states. So they have variable oxidation states. So even the compound itself also can make another intermediate compound because of the loss or the gain of electrons. So this is the only reason for which the transition metals are found to be very, very good catalyst. This is very important for your coming exam. So I'll write down. So I have just explained to you the theory of catalysis. This is called theory of heterogeneous catalysis. So I'll write now. All right. Their catalytic activity can be explained by what? They provide a very active surface area for absorption. What is the meaning of this? Because transition elements have very strong, because their size is small dear, and they have very high effective nuclear charge. Because of that, they pull the substances nearby. So they provide a very active surface area for absorption due to their higher effective nuclear charge. Or you can write charge by radius ratio. So charge by radius ratio may be a little difficult for you to remember. Second, they have unpaired electrons in their d orbitals as well as vacant d orbitals to form transition to form intermediate complexes. At least in chemical kinetics, you have already seen that they form intermediate complexes. This second. Then third, I'll write transition metal compounds or ions also exhibit catalytic property and is due to their variable oxidation state.
Yes, sir.
So now we are going for all these things that we are discussing now. All of them are important, and but most of the time you'll find their answers are same. Everything depends upon their unpaired electrons. So now we are going to discuss two more properties that based on their sizes. So now it's called formation of interstitial compounds. Now, what is interstitial compounds? You see first. See, these are the atoms. So please excuse me for bad drawing. See, these are the atoms. See, these empty spaces are there now. These empty spaces are called interstitial spaces. So, small atoms of a periodic table, they can come and occupy this space. Okay? They can come and occupy this. So, in that case, whatever this compound is being formed, we call them, they do not form any bond, they only get trapped. Okay? So, these are called interstitial compounds. So, what are those elements can be trapped inside? It can be hydrogen, it can be beryllium, it can be boron, it can be carbon, it can be nitrogen. Okay? So they do not form any formal bond, but they remain there. So these type of compounds are called interstitial compounds. What will be the effect of them? Obviously, see, when you pack all these empty spaces, these type of compounds become very hard. You cannot compress them. Moreover, we know metals have a unique property of malleability and ductility. So when you have taken say you have taken this metal iron cube, okay, and you have started warming it and beating it. So in that case, you can make a big sheet out of it. How does it happen? See, this is the first layer. Okay, this is the first layer, and this is the second layer. So first layer you have empty spaces are there. So the atoms of the second layer slip through the first layer, and their surface area is being extended like this. So if you block them, then the atoms from the inside layer cannot slip through. In that case, you will find that interstitial compounds lose their malleability and ductility. Third, they lose their chemical reactivity. Okay, when interstitial compounds are found to be non-reactive or chemically inert, because when two elements they combine with each other, they exchange electrons. So the adjacent place near to their metal should be free. But all these places you have blocked. So when you block all these places, then they cannot react with others. Okay, so let me write. I should not write also. All these things are given in your book. Transition metals form a number of interstitial compounds with small elements such as hydrogen, carbon, boron, nitrogen, etc. These small atoms get trapped within interstitial spaces. In the lattices of transition metals. Please remember, for entrance exam, interstitial compounds are formed only by transition metals. S block cannot form, P block cannot form, and even the inner transition elements also cannot form. Because it depends on their sizes. If the interstitial size is very big for S block elements, then the element will enter from one side, go out from the other side. And if you go for P block and the inner transition element, the sizes are small. So the interstitial spaces are too small for them to enter. So they give you the ideal home for them to stay. Okay, what is the characteristics? One. These are generally non-stoichiometric that you already read in solid state. Non-stoichiometric and neither typically ionic nor covalent. In these compounds, malleability and ductility decreases. It is because all the interstitial spaces, it is because all the interstitial spaces of the surface is blocked. And so the inner atoms cannot slip through to extend, to expand their surface area. This is important for example. This one, second, put a star. Then third, these are extremely hard and some boride compounds. Boride means contains boron. Attain hardness equivalent to diamond. They have very high melting and boiling points. Higher than those of your metals. Fine. These are chemically inert. Please remember, the cast iron that you have or the normal steel that you have, these are interstitial compounds. In the ordinary steel, only iron and carbon is there. Cast iron also iron and carbon is there. We are not going for specially designed steel. Okay, due to that, you'll find the cast iron and the normal steel, they do not undergo rusting. Why? With all the empty spaces where oxygen is supposed to sit and react with iron are being blocked with carbon. So these are chemically inert. They retain electrical and thermal, there is no, in that case, the thermal conductivity and electrical conductivity does not decrease. So written electrical and thermal conductivity. बस हो गया. So now one more we'll do is the formation of alloys. So alloy, you know, is a mixture of two metals. In transition metal, their atomic sizes are almost same. So one can replace the other in the crystal lattice, leading to the formation of alloy. Alloy formation. Transition metal form a large number of alloys. Since D block elements are quite similar in atomic size. The atoms of one metal can replace the atoms of other metal in its crystal lattice. To form alloys. Alloys are generally harder, stronger, has desirable casting. What is the meaning of casting property? That is, you can give any shape to it. Casting properties have high melting points and more resistant towards corrosion. See, because of that, steel does not rust. Then the individual metals. Okay. So example लिखो. Example, you know what is this? This is example. Please some of the example you should know for your entrance exam. Okay. Brass contains what? Copper and zinc. See, zinc is 225 picometer. Copper is 119 picometer. So almost same. Then bronze. Copper, zinc, tin. Okay. Then steel, na? Please, different types of steels are there. See from book. So don't write here. See from book. Various metals are there. From book you write down for your entrance exam. Okay. So I shall meet you when? Tomorrow, na? Today is Thursday, na? Yeah, tomorrow.
Thank you, sir.
There are around 6-7 classes to finish this one. I cannot go hurriedly. Okay, bye.
Thank you, sir.
Bye, sir.
Bye, bye, bye.
Yes, sir.
তোমার ডেডিকেটের সামনে ইস্যু করে গেছে হ্যাঁ